Okay, section 5 is going to look at the idea of some logarithms a little bit further with a little bit more complicated expressions and basically going to introduce some shortcuts on how you can rewrite some of these. In some cases, we're going to expand an expression. In some cases, we're going to condense the expression, mostly for the purpose of being able to do some simplifying. But we're going to talk about these rules and then talk about how some of these are going to be, what they'll look like when we get to them in the expressions. Okay, so first of all, one of the things that we can do, and we kind of illustrated this with some of the problems, is that anytime you have an expression where you have a base here and a base here that are the same, okay, they will cancel out so that the only thing that's left is your exponent. Okay. Now, again, I could show you the equation beside this, but this is just a shortcut in case and you wanted to, in case you identified it. So, in other words, the log of 6 of 6 squared has to equal 2. Okay, because that log base 6 and then the base of your exponential part more or less cancel each other out. Okay, now here's another one. If you have log base 7 of 49, well, that's the same thing as log base 7 of 7 squared. Okay, same thing happens. Okay, the log 7 and the 7 cancel out. Again, you have left with 2. Okay, now if it's given as an exponential form, it looks a little bit differently. So if you have 3 raised to the log base 3 of 4, for example. Okay, so it's exponential, but it has a log in its exponent form. In this example, those cancel out again. So this, whatever's left up there, is going to be your answer. Okay, so these are special cases that allow you to do some simplifying. They will throw some of those in. So just be aware of that. So let me give you a good example of what it's going to look like on both test and homework. If I have the natural log of e to the 4th power, okay, then remember what natural log stands for. That's log base e of e to the 4th. And we just said that whenever this base down here and this base are the same, all of that drops off and you're left with 4. But it looks like that to begin with. Okay, so we can use that same idea to take some expressions and rewrite them in simpler form. Okay, so that will be one of the issues they'll be trying to tie in. Okay, now the other part of this is going to deal with operations. Okay, so remember when we were doing in polynomials, we had a product rule when we were dealing with exponents. Okay, product rule says if you have, and this is for logarithms, if you take the log of the product of 2 items, you can actually write that and break that up into a sum of their individual logs. Okay, now the bases have to stay the same. If this is log base b, then this is log base b, and then this is log base b. Okay, but a multiplication here changes to a summation here. Okay, that's the product rule. Quotient rule if I have log base b of x divided by y. Okay, then again, same idea. I can break it up at this time into a difference of logarithms. Okay, so you're going to see that. We're going to be rewriting some expressions here. In some cases, we're going to start with an expression on the left and end with an expanded form, like on the right. In the second group, we'll start with the problems on the right and then move backwards. The last one is called the power rule. And some of these will have a combination of. So the power rule says if you have a log and you have something raised to a power, something like that, we're allowed to write that as a product by taking the exponent off and bringing it out in front. Okay, so product rule, we multiply, we change it to an addition. Division, we change it to subtraction. An exponent, we bring it out in front and multiply. Okay, that's where if we're going from this way to this way, and each one of these is going to be reversible. We'll use it the other way as well. Okay, so those are the rules we need to talk about. There is one more, and I'll wait till we get to that part. Well, no, I better not, because it's the first one of the first questions. In the previous section, I talked about how the calculator can only do base 10 and base E. There is a formula called a change of base formula. And the change of base formula allows you to do just that. Change the base to one that you can use on your calculator. Okay? So if I'm given something like log base 6 of 12. And it says find or approximate this value to 3 decimal places. Okay? Well, here's what you're going to do. First of all, pick a base that's on your calculator. You can use common log or you can use natural log. So common log is base 10, natural log is base E. So I'm going to write it out using both. When you actually punch it into your calculator, it doesn't matter. You'll get the same answer. So, so here's what I'm going to do. Using common log, this would be log 12 over log 6. The big number here goes on top. The little base goes down here. You're dividing those logarithms. If I wanted to use natural log, switch the wording, but nothing else changes. Okay, but change of base looks like this. You take this, you break it up into the two parts, you type it into your calculator, you round to 3 decimal places. Okay, so you've got some of those to do as well. And once you've got it set up, it's just a matter of typing it in. Okay, now, so let's look at what we've got on the exercises. Okay, questions first of all, 1, 2, and 3. Okay. On question number 1, true or false, okay, the natural log of x plus 3 minus the natural log of 2x equals. Okay. Well, this is one of those simplifying steps. Okay, I've got it expanded into 2 natural logs on the left side. I'm trying to condense it on the right. Okay, now subtraction sign means division. So they changed it to a division problem. They put the first on top and the second on the bottom. Okay, but there's a problem with this because notice they still left both natural logs, okay, in there. If they would have put that natural log out in front and used it only once, the problem would be correct. Okay, but in this form as it is not. This one is not correct, so I would answer false. Okay. In the second example, number 2, true or false, log base 2 of 3x to the 4th power equals, and you notice they took the 3 or the 4 and they brought it all the way out in front of that expression. Okay. Now, again, there's a problem here because that says that the 4, exponent 4, goes with the 3 and the x. It does not. It only goes with the x, so that thing should have been broken up using an addition sign. So if they would have written it like this, log base 2 of 3 plus 4 times log base 2 of x. The 4 goes with the x, so it would only go in front of this, not in front of the whole thing. So they actually should have performed a different step, an additional step there before they brought the 4 out. So again, this is also a false. Okay. Number 3, they're using the change of base formula. They use natural logs. They put the 16 on top and the 2 on the bottom. That one will work. Okay, that's a true statement. Okay. Questions 4 through 8. They're asking you to simplify without using the calculator. Okay, so here's where that first round of shortcuts that I talked about comes into play. Notice what's on the bottom, what's on top. Notice your bases, your exponents. You have some things that are going to cancel out because they have similar bases. Number 6. Okay, it's an exponential form. It's 2 raised to the log base 2 of 7 power. Okay, so because of the form where the 2's are the same, everything, though, all of that drops out. So all that you're left with is a 7. Okay. Number 8 is a little bit different. We've got an extra step we can plug in. Okay. So in this case, log base 6, the addition sign is going to change to multiplication. So this is log base 6 of 9 times 4, which is log base 6 of 36. Well, I see some overlap here. 36 is the same thing as 6 squared. Now I have some similar bases. Log base 6 here. They cancel out. All that's left is the number 2. Okay. Next group of questions. Here's where we're going to start expanding and condensing. Nine through 13, a little too high there. Okay, so it says rewrite each expression as a sum or a difference of logarithms. Okay, express powers as factors. Okay, so number 10. Okay, number 10 as a fraction, in other words, as a division. So that means I can split it up and write it as a subtraction. So I'm going to write this as log base 3 of x minus log base 3 of 9. Okay. Number 12 has got a couple things going on. 13 has another quotient rule again, but I've got a product rule going on number 12. Okay, so I'm going to write this as an addition, but I also have some exponents. So I'm going to do the addition part first. I'll do this in 2 steps here. So log base A of u squared plus log base A of v cubed. Okay, that's the first step, is to break up the product. Second step is to pull the exponents off. The powers, it says take the powers, write them as factors. That means bring them out in front. So that's 2 times log base A of u plus 3 times log base A of v. Okay, there's your answer. 13 will look similar. It's got a minus sign instead of a plus sign. 9 and 11 are a little bit simpler. 14 through 18, this is just the reverse. These have been expanded. Okay, we want to put them back together. So lots of subtractions. Didn't really mean to do that to you, but okay, so let's look at number 17 and 18. So 17 says log base 4 of x squared minus 1 minus 5 times log base 4 of x plus 1. Okay, so I want to convert those to a single log base 4. I have log base 4. Subtraction means this is going to be a quotient. I have x squared minus 1 on top. And I have x plus 1 to the 5th power on the bottom. Okay. Excuse me. Now, here's what I know. X squared plus 1, or x squared minus 1, factors into an x plus 1 and an x minus 1. X plus 1 to the 5th power is x plus 1 times x plus 1 to the 4th power. Cancel out the x plus 1s. And so I'm left with log base 4 of x minus 1 over x plus 1 to the 4th. Now, you're not going to have to do much simplifying. That's why part of the reason I chose this problem is because it's a little bit above and beyond. But it's, look for things like that. If you can combine some things, simplify some stuff, okay, simplify. Do it. Okay. On number 18, similar. This will also. This is a common log. Log of x squared plus 3x plus 2 over x plus 1 squared. Still going to simplify. X on top, I get an x plus 2 and an x plus 1. On the bottom, I have x plus 1 times x plus 1. Cancel those out. So I had left with a common log of x plus 2 over x plus 1. Okay. 19 through 23. Here we're using the change of base formula. And then once you have your change of base, then just type it in, round your answer. So number 21, if I choose to use the natural log on this one, this would be natural log of 7 divided by the natural log of the square root of 2. Okay, and I'm not going to punch these in. I'll let you punch those into your calculator on your own. But be careful and as you type those in, and then round to 3 decimal places. On 23, I'm going to use common log on this one. So common log of square root of 2 divided by common log of pi. And again, just type them in and go. Okay, so this is again a little bit longer. The last part of this takes a little bit more to deal. The first part of this is kind of short. Okay, but either way, send me any emails on questions you're still having on this section. When you get done with this section, go to the test, complete those, and then we'll move on. The two sections we have left, 6 and 7. 6 is on solving some equations, and 7 is on an application of where you're going to see some of these being used. Both of them are kind of short assignments, so those won't take as long as the first part of this does.